So this lecture is about everyday forces. So we experience several types of forces daily. Here's an image of two children who have a wagon. One child is pulling the wagon with a rope, another one's pushing the wagon from behind. Let's analyze the forces that are acting on this wagon. And one way we can do this is with a system diagram. A system diagram would be something like we see here. So we just kind of sketch out what's actually occurring, and this gives us an idea of the forces involved. The next thing we would do, though, is to turn that system diagram into what's called a free body diagram. And a free body diagram takes the system diagram and simplifies it down to something simple like a single box, for example. So that box represents the object that forces are being acted on. We don't need the children anymore. We're just going to look at that box, and we're going to label each force that interacts with that box. And we label each force as F, capital F, with a subscript indicating what type of force it is. So first we have the applied force. We can say the applied force here would be the pushing by the child or the pulling by the other child, or it can be a combination of those. So here our applied force is acting towards the right. Now let's say that the applied force is that child from behind who is pushing. Then the other child who's pulling is holding onto a rope. Well, a rope itself has another type of force called a tension force. And in this case, it is going to be in the same direction as the applied force. So those two forces would act together to attempt to move this wagon towards the right. Another force we have is called the normal force. And the normal force is a perpendicular force that keeps something from falling through the floor. So anytime you have an object that is on solid ground, all objects would have the force of gravity acting on them. But if an object is on solid ground, then they also have a normal force, which is the force that the floor or the ground applies to the object to keep it from falling through the ground. Another type of force is friction. So when we have something that is moving against the floor or against the ground, depending on what surface it's moving on top of, there would be a friction force that would prevent its motion in the direction that it's being pushed or pulled towards. So friction always it kind of acts against the applied force, or it's always in the opposite direction of the motion. So those are contact forces, and contact forces are forces that occur because something's in direct contact with it. The normal force and the friction force occur because there's contact with the floor. The applied force is occurring because a child is pushing. The tension force is occurring because it's attached to a rope that's being pulled. There are non-contact forces as well, and the main one we deal with is the force of gravity. But there could be other ones. We could have an electric force, a magnetic force, also acting on something as well. So the force of gravity is our main non-contact force. It is opposing that normal force now. And quite often you'll find the force of gravity is equal to the normal force, though not always. So the force of gravity is an example of a non-contact force. To calculate the force of gravity acting on an object, there's a simple equation. It's just mass times g, where g is that 9.8 meters per second squared, the acceleration due to gravity. And we'll get into that a little bit more later, But that's how you would find the force of gravity acting on an object, just mass of the object times 9.8. This is an important slide to copy down, so you might want to copy down all this information here. So Fg is the force of gravity. It's the force of attraction between the Earth and an object. Fn is the normal force. It's the force that's perpendicular to the surface on which the object rests. Ff is a friction force. It's the force that opposes attempted motion of an object. Fa is the applied force. That's the force exerted on an object. And if an object is attached to a string or a rope or some other type of device that might have some tension to it, Ft is the tension force. That's the force exerted by a string or a rope on an object. So there are also, we had talked about contact and non-contact. Another way to look at forces is internal forces and external forces. So external forces are forces that occur kind of outside of an object. These are the forces that would show up in a free body diagram. Internal forces occur when an object exerts a force on itself. So these would be forces that would not show up on a free body diagram. Let's look at an example here. If we have a skater 1 and a skater 2, if skater 1 pushes on skater 2, that is an external force on skater 2. But if skater 1 pulls forward using her own arms, then it's an internal force. If she's pulling herself forward, so she's making herself move. She's pulling herself using skater 2 as kind of like the person she's pulling against. That is an internal force. Here's the definition of a free body diagram. It's a simple drawing representing an object being analyzed. It includes all external forces acting on the object. So here are some simple free body diagrams, and I won't go through all of them, but the first one here, it's a cup resting on a table. There are no forces attempting to move this cup off the table. The only force really that's acting on it, the only non-contact force acting on it is the force of gravity. And because of that, we have a normal force that is keeping it from falling through the table. And in this case, the force of gravity would be equal to the normal force. This is about a trunk that is being pulled by a rope. So this trunk, it's being pulled by a rope, so there's a tension force that's pulling it towards the right. The trunk does not move, so the force of friction acting against that would be equal to the tension force. It would be enough force to prevent it from moving. There's also a gravitational force and a normal force, and those would be equal as well. And you might have noticed we have two situations where nothing has moved, and that's occurring when we have equal forces in both the x and y direction. That prevents something from moving. In order to get something to start moving, we need to have an unbalanced force situation. Here's another one. This one's interesting. So we have a baseball player sliding to the left across the ground. So this baseball player is trying to slide into a base. And you might think that that's an applied force. They're sliding. But as soon as the baseball player gets into a slide, there is no more force that is pushing them forward with the slide. They are only experiencing a frictional force slowing them down. And they also have a gravitational and a normal force as well. Here's one with a desk that's being pushed across the floor. There is an applied force, a friction force, a normal force, and a force of gravity on that one. So here I'd like you to try this, and you can kind of look in the textbook for ideas to see if you're doing it correctly, but either mentally or on paper, draw some free body diagrams. One of them here is a free body diagram of a textbook resting on a desk. Another, a tennis ball falling through the air. And I don't want you to consider air resistance. So you just have a tennis ball and it's falling down through the air. What are the forces acting on that? Lastly, we have a dog sled moving slowly along a flat but rough snowy trail. It gets pushed horizontally by the sled owner, and it's also being pulled horizontally by dogs attached to it by a rope. So we have a person behind this sled pushing it forward. We have dogs in front of it pulling it, and it's on some rough terrain. I'll give you a hint on that one. There are 5 forces for this one. And actually, sorry, this is the last one. We have a wagon with a small child sitting in it, and the wagon's being pulled by a rope up a steep, bumpy hill with a rope parallel to the hillside. So consider that one as well.